Good morning, students. Welcome to our second lecture on circuit theory. Today we will start our discussion on two very common terms which are system and signal. Let us start with system first. Now, a system is a combination of elements. What is a system? A system is a combination of some interconnected elements which together produce a output. Produce an output. Okay, the number of inputs or outputs may be more than one. As for example, let us take the example of an education system. Here the input is say students and teachers, and the output is the educated professional. This is what an education system. The elements here are school, colleges, etc. Now let us take the example of the digestive system. In a digestive system, if the input is carbohydrate, it will end up to glucose. Okay, but here we will confine our discussion to the electrical system only, where there is a fixed mathematical relation between the input and output. We will confine our discussion to the electrical system, where there is a fixed mathematical relation between the input and output. Okay, now you must have noticed that here we are representing a system merely by a box or a black box. We can do it only when we are interested to look a system as a whole. We are not interested to calculate the signal value within. The system behavior here can be understood by the input-output relationship in this approach. Let us clean the board and proceed again. Can be expressed as xt and output. We will express the output as yt. Input is often called as excitation and output is often called as response. As a whole, the representation of a system is xt is the input and yt is the output. In a nutshell, we will represent a system as xt arrow yt, and we will read this as xt gives rise to yt. Now in electrical network, all xt and yt, all are voltage and current. All the inputs and outputs are voltage and current. Okay, now we can classify the system in many ways. Let us see the ways. We can classify the system in many ways. What are the ways? We can classify the electrical system firstly by classified into the electrical system can be classified into a lumped system and distributed system. Now electrical system can also be called as network, so we can call it lumped network and distributed network. Now what a lumped system or lumped network is? Now if the physical dimension of the network or physical dimension of the system is negligible compared to the electromagnetic wavelength passing through it, then the system is called a lumped system. We know that if f is the frequency of the electromagnetic wave and lambda is the wavelength of that wave, then f into lambda equal to what? Equal to c. C is the velocity of propagation of the electromagnetic wave. What? The value of c is 3 into 10 to the power 8 meter per second. Now, for a 50 Hz network, if f equal to 50 Hz only, then lambda equal to what? Lambda equal to 3 into 10 to the power 8 by 50 meter. That is 6 into 10 to the power 6 meter. That is 6,000 kilometer. The wavelength of the electromagnetic wave is 6,000 kilometer. Now, the physical dimension of the circuits we handle in general, the physical dimensions are very much less than this wavelength. Therefore, all these are lumped network or lumped system. Now, for a microwave system, let us take the example of a microwave system with f equal to 10 gigahertz. 10 gigahertz means 10 into 10 to the power 9 hertz or 10 to the power 10 hertz. So lambda there equal to 3 into 10 to the power 8 by 10 to the power 10, that is 0.03 meter or 3 centimeter. Therefore, for microwave system, often a tiny circuit is the physical dimension of the tiny circuit is comparable with the wavelength. So there, that circuit will be called a distributed system. Now, for a transmission line of say several thousand kilometer, say 500 kilometer transmission line. Now, which carries a 50 Hz voltage or current. Now, this cannot be treated as a lumped network this will be treated as a distributed network, distributed system or distributed network. Now, one very important aspects of distributed and lumped network are the very well known two equations KCL and KVL. These can be applicable only in lumped network. We cannot apply these KCL and KVL in the distributed system or distributed network. Okay. Now system can be classified in terms of number of input and output also, like a system can be classified as number of input and output also, like say this is a SISO system, that is single input single output system, whereas we can call this system as a MIMO system or multiple input multiple output system. The dimension of this system is M cross N, where M is the number of input and N is the number of output. Okay. Now the characteristics of a SISO system can be completely represented by a transfer function. The characteristic of this system can be represented by a transfer function, whereas the transfer function approach is not applicable to a MIMO system. Now, the next classification, we can classify the system as a static system and a dynamic system. The system can be classified as a static system and dynamic system. We can often call a static system as a memoryless system. Now the characteristics of a static system is the output at a particular instant depends on or function of the input at that instant only. Now nothing else. The output of a particular instant depends on the input at that instant only. Now, for a dynamic system, the output depends on not only the input at that instant, but also the differentiation of the input, the integration of the input, and if there is a stored energy, then also the output depends on that stored energy. Now the characteristics of a dynamic system is the output at a particular instant is a function of the input at that instant, the derivative of the input, the integration of the input, the stored energy in the network, etc. Now, the characteristics of a static system can be described by an algebraic equation, whereas the characteristics of a dynamic system can be described by one differential equation. Now, let us take the example of a static system and a dynamic system. Now, if we consider only a resistive circuit, then we can call it a static system, because the output, say we will call the current through the resistance as the output and voltage applied as the input. Then the system can be represented as Vt gives rise to It, and I depends on the voltage at that instant only. So this is a static system. Now, whereas a RLC network or RLC circuit, we can call a RLC circuit as a dynamic system or dynamic network. Okay. Now, the next method of categorizing a system is continuous time system and a discrete time system. Next method is of categorizing a system is continuous time system and discrete time system. Now, for a continuous time system, the input-output relationships are valid for every instant of time. Now, the input-output relationship is valid for every instant of time, whereas a discrete time system is that where the input-output relationship is valid for discrete points of time axis. The input-output relationship is valid for the discrete points of time axis. This is, say, output. Okay. Now, in discrete time system, we are interested to calculate the output only at these instant or these particular times. Okay. The intermediate values may not be available. The intermediate values may not be available, and even if they are available, we are not interested with this. Okay. Let us take the example of a continuous time system and discrete time system. Say one RC network is there. Here, this is the input, the source voltage is the input, and we will call the voltage across the capacitor as the output. So here the input is, say Vi or input voltage and output voltage is Vc. Now the governing equation is what? Vc plus Vr equal to Vi. Vr is the voltage across the resistance, or Vc plus I into R equal to Vi. Now, if the voltage across the capacitor is Vc, what will be the value of I? I equal to C dVc dt. So let us replace I by C dVc dt. So we will get RC dVc dt plus Vc equal to what? Vi. Now that is dVc dt plus Vc by Rc equal to Vi by Rc, or we can write here is d plus Rc Vc equal to Vi by Rc, where d equal to what? D equal to ddt. Now this equation is defined for every instant of time. Now let us take the example of one discrete time system. Say we are interested in calculating the population of a country. Now say Yn is the population of the country at the start of nth year, and say Xn is the number of persons died in nth year, and say Pn equal to the number of persons born in nth year. So we can conclude that the population at the start of the next year equal to what? The population at the start of the next year, that is n plus 1 year, is equal to Yn, the number, minus Xn plus Pn. Okay. Now we can go one or two steps up or down. That is Yn, we can write it as a subscript or in bracket. Yn equal to Yn minus 1 minus X n minus 1 plus E n minus 1. Okay. Now n will only take some integral values. Now this equation is called the difference equation. Now in RC circuit, the governing equation was a differential equation, but we will call this equation as a difference equation. Now the order of the difference equation is the highest and lowest index. The order of the differential equation is the difference between the highest and lowest index. That is, here the order is highest index is n plus 1 and lowest index is n. So this is a first order difference equation. Okay, now in this course we will discuss about only the continuous time system. Now we can classify the system as a linear system and a non-linear system. The system can be classified as linear system and non-linear system. What a linear system is? If x1 gives rise to y1 and x2 gives rise to y2t, then for a linear system ax1t plus bx2t together will give rise to ay1t plus by2t, where a and b are constant. That is, it follows the principle of both the superposition and homogeneity. Okay, now if in a network, in an electrical network, if there is an independent source or if there is an energy storing element, the system will not be a linear system. Let us explain. Let us take the example of this resistive network. Now, although resistance is a linear element, but if 1 ohm resistance is in series with a 2-volt battery, then will it be a linear network or non-linear? The answer will be this is a non-linear network, because say this is the input voltage Vi and this is the current, and this current is the response and this is the input or excitation. Now 5 volt will give rise to what? If Vi equal to 5, then I equal to Vi minus 2 by 1, that is Vi minus 2. So 5 volt will give rise to 3 ampere current and 10 volt will give rise to what? 8 ampere current. Now, so if this obeys, if this will be a linear network, then 15 volt should give rise to 11 ampere current, but 15 volt here, the result of a 15 volt is what? 13 ampere current. So this is not a linear network, so this is a non-linear. Now let us take the example of a capacitance. Say one capacitance is there. Now the input here is a current source. The initial voltage across the capacitor is rho volt. Rho volt is the initial voltage. If there is no initial voltage, then voltage across the capacitor Vc will be 1 by C I dt. As there is one initial voltage, then Vc equal to 1 by C integration I dt plus rho. Integration 0 to t, then we will call it Vct. So we can call it a system with input I and output Vc. Then I1 will give rise to what? Vc1, where Vc1 equal to Vc1 equal to 1 by C integration 0 to t I1 dt plus rho, and I2 will give rise to Vc2, where Vc2 equal to 1 by C 0 to t I2 dt plus rho. Now I1 plus I2 will give rise to what? I1 plus I2 will give rise to Vc3, where Vc3 equal to 1 by C 0 to t I1 plus I2 dt plus rho. Instead of 2 rho, this will be rho. So this is not a linear system. This is also a non-linear system. Now a linear system is governed by a linear differential equation, whereas a non-linear system will be governed by a non-linear differential equation. What is a linear differential equation and non-linear differential equation? A linear system is governed by a linear differential equation, and non-linear system will be governed by a non-linear differential equation. The linear differential equation is one where the coefficient of various derivative terms are not the function of the dependent variable. Say dy dt d square y dt square. Here y is the dependent variable. Now the coefficient of dependent variable, this may be constant, this may be the function of x, but this may not be the function of y or the y itself. Okay, now if this term appears, then we can conclude that the system is a non-linear differential equation. Okay, these are the non-linear differential equation, the part of the non-linear differential equation. Okay, now let us take the example of some differential equation. Say 4 d square y dt square plus 3 dy dt plus 5y equal to 2x plus 5 dx dt. This is what? This is a linear differential equation. Now let us take the example of this one, 4t d square y dt square plus 5 dy dt plus 6y equal to say only 3x. This is again, this is a linear differential equation. Now whereas this is this 4y dy dt plus y equal to say 3x, this will represent a non-linear differential equation. Okay. The next category is time variant and time invariant system. The next category of system are time invariant and time variant system. Let us see what a time variant and time invariant system is. Now time invariant is a constant parameter system. Whereas time variant system is a variable parameter system. Now in an electrical network, if the R, L, C are all constant, then if these are constant, then this will give rise to a time invariant system. Now for a carbon microphone, the resistance depends on the input. Hence, for a carbon microphone, this system, the carbon microphone system, is a time variant system. Okay. Now, for a time invariant system, say xt gives rise to yt. Now, if xt is delayed by a time d, then yt will also be delayed by the same amount of time. Now let us take the example of one differentiator. Now for a differentiator, if the input is this one, this is a straight line, if the input is this one, the output will be this one. Now if we delay the input by a time interval d, the output will also be delayed by the same time interval d. Okay, so the system is a time invariant system here. Now the next way of classifying a system is a causal system and a non-causal system. Now for a causal system, say x1 gives rise to y1 and x2 gives rise to y2. Now for t less than t0, x1 equal to x2, then for t less than t0, y1 equal to y2. If this happens, we can call it a causal system. Now we can conclude that for t less than t0, if x equal to 0, then for a causal system y equal to 0 also. Okay, now a system which is not causal is called a non-causal or anticipatory system. Okay, now let us introduce another term which is relevant in this regard. A causal signal is one. A causal signal is one where xt is equal to 0 when t less than 0. Okay, now we can also classify the system in terms of number of independent variables associated. Now what did I say? We can classify the system in terms of the number of independent variables associated. Now let us take the example of an electrical transient system. Here the voltage or current are the functions of time only. So these can be classified as the one-dimensional or 1D system. Now in case of a long transmission line, the voltage at any point is a function of both the time and the distance from the sending end. So the long transmission line is the example of one 2D system. Now for a electric field, the voltage at any point is the function of its coordinate. So for electrical field, a three-dimensional electrical field, the voltage at any point are the function of it. So we can conclude that this system is a 3D system. So we could classify a system in 8 number of ways. Now in the course of circuit theory, we will discuss about the linear, time invariant, causal and 1D system only. Okay. Now let us conclude here for today. In the next class, we will start discussing about the signals. If you guys like our video, then please like, share and subscribe our channel. Thank you.